Hello guys, today I'm going to present to you or give you a brief example of how to find a determinant using cofactors. I think all of you are all familiar with finding a determinant of a 2 by 2, but then if we still have people who are struggling finding the determinant of 2 by 2, maybe I can just start off by giving an example of how to find the determinant of a 2 by 2 matrix. So a 2 by 2 matrix is found it's found by multiplying the diagonals, the numbers that appears in diagonals. Like you take the entry A11, multiply, and then we just multiply this by A22, and then the second thing that we're gonna do is you subtract from this answer that you get, because here we'll get something like A11 multiplied by A22, and then you just subtract the product of A12 multiplied by A21. So, and that will be minus the product of A12 by A21. It might not be clear enough, but that's what I'm trying to say. So, okay, so the answer for this one will be of a 2 by 2 matrix. Answer for a 2. Okay. So the answer for a 2 by 2 matrix will be given by is given by A11, it's right there, so it's A11 by A22, so it's this one, the diagonals, A22, and then minus A12 by A21, as you can see here. So it's A12 by A21. A21. Okay, and then that's pretty simple. But then the problem comes in whereby we are having a bigger matrix. So as we can see here, we can't just say, we can't use the diagonals. We can't use the diagonals for this one, because if we do that, and then we'll have something A21 and then A23 left in the matrix. So what we'll do by saying we'll be using cofactors, we'll kind of try to reduce this matrix to a 2 by 2 matrix. And then before we do that, we are also trying to we are also trying to to give or to assign signs, different signs, either plus or minus. So the signs will be alternating between the entries, like either one minus one or minus plus one or minus one or plus two, depending on what is the position of the entry that we are that we'll be dealing with in the matrix of cofactors. So if you are using cofactors, then we are saying we kind of trying to reduce this matrix here. So let me just give you an example before we go on to the question that we want to do. So we are kind of saying let's just have different two more matrices here, because as you can say, so I think we will have at least a clear example. I just want to have one more matrix or two more matrices here. Okay. So we are now having that matrix. And then I just want to have three more matrices there. Another matrix. Okay. So we are saying we are trying to reduce these matrices to a 2 by 2 matrix. So what we'll do, we'll just select any of the row, just any of the row we want to choose, and then it doesn't matter whatever row we choose, so we'll still get the same determinant, or the determinant will still be the same or equal. It can be that we choose the first row or second row or the third row, and then expand through that row. Okay, so what we're gonna do, we'll cancel one of the column and then one of the row again. So then we will see that our lines intersect at the first entry. See that? And then we are now having a beautiful 2 by 2 matrix here that we can figure out, or that we can work out to get the determinant. But then we have to repeat this n times, or what we mean is, because we are having a 3 by 3 matrix, we have to repeat also this process 3 times using the row that you just selected. Like in this case, we have selected row 1, but also this matrix here. So we are saying we have to find the determinant of these 2 by 2 matrices, but we have to multiply it by the entry where our lines intersect. So we are saying this will be A11 multiplied by the determinant of, so it's multiplied by determinant of this, of a 2 by 2 matrix, or a matrix of cofactors. Okay, but then we want to figure out what exactly is the sign of A11. So we kind of say we multiply this A11 by -1, and then we raise that to the power of the sum of the entries position, which is 1 plus 1. So this will be 2, and then of course that will give us a plus 1. So in this case our A is positive. Okay, and then we move on to the here now. So I just made this, duplicated this 3 times, so that it will be clear for you and easier for you to figure out what I'm trying to say, or what I'm trying to do here. But you can we can definitely do this one also just using the same matrices. But for clarity, let's just do this so things will be clear for everyone. So we move on, as we have stated earlier, that we only select one of the row. So previously we selected row 1, so we still use that row 1, but now in position 1, 2. So as we can see here, still our line intersects at A12. So we are going to use that A12, and then we multiply it with the 2x2 matrices, or the determinant of the 2x2 matrices, which is this one. As you can see, is this, and this, this, and this. So it's like we'll be multiplying this one out, and then we're subtracting this times this. So pretty simple. So we now multiply with the determinant of a 2x2 matrices, which is this one times this minus this times this. Okay, but we now again we want to find out what will be the connecting sign between this and this. So as we have said, stated earlier, we erase this one. We just put a -1 here, -1, and then we raise it to the power of the entry position, which is 1 plus 2. So this, in this case, it will be 3. So in this case it will be 3, and then this one will obviously go to -a. And then what is left is the last column, which I'll do in this one. So as we said before, we delete that one, and then we see where our line is intersecting. It's intersecting at 3, 1, 3. I mean A13, and then we still have a beautiful 2x2 matrix here. As you can see, or we can say is matrix of cofactors. So cool. As you can see, we can just multiply out this one also to give us the determinant, but and then we use this one, which is A1/3, 1/3, but we want to figure out what is the sign here. So the sign will be given by position 1 and 3. So it's 1 plus 3, which is 4. So anything to the power -1 to the power 4 is positive. So this one now becomes a positive, just like this one. So now it becomes a positive, because if you square something, if you square a negative of a number, then it becomes a positive. So we can also say that any number, any sum of the entries which is even gives us a positive. Like as we can see in this example here, if you're having 1 plus 1, it is even because it's 2. So this one will just be plus, and this one will be minus, because 1 plus 2 is 3, which is odd, and then this is 1 plus 3 is 4, is plus. So we kind of alternating signs. But if we were to select this one, then it will give us 2 plus 1, which is 3. So this will be minus. And then if we were to select this one again, it's 2 plus 2, which is 4. So that will be positive. And then this will be minus. So it's just kind of alternating signs. You can try this one, and then always you see that it's just alternating signs. So the determinant of this one times the entries that from which we are expanding through. Okay, so let's now figure out what is the answer, what is the determinant of a 3 by 3 matrix in reality now. So let's do this. So we delete this one, and then we now want to figure out what is the answer for this matrix. So as we have stated before or earlier, we can say, let's remove these things here. So we now kind of saying we want to find out the determinant of this. So using the same method as we discussed earlier, we can select to expand through this one if we want, but we can also do it using any other row. So if we do that, we can clearly see that we are having our beautiful 2 by 2 matrices here. So we just write that one and see what is going on. So we now have 0 times 2, so that's 0 times 2, and then we subtract, but before we do that, we first want to find out what is the sign for this one. So as we've said earlier, this is 1 1 and 3 1 1, so it's positive, then minus, then positive. Okay, so let's just expand right away using the entries that we are expanding with, or just multiplying out already. So this is 1, so it is now plus 1 because the sign here is plus, and then we just multiply that one with the determinant of a matrix, which is 0 times 2, 0 times 2, 0 times 2, and then from that we subtract subtract 1 by 3. So it's minus 1 times 3. Okay, and then now we want to find out what is the sign between here. So it's 2, it's minus, so we put this sign here, minus, and then we take this 2, so it's 2, and then we just want to clear that away, and then we now use this one. So we are now having 2 by 2 and 3 by 1. So we just multiply out using that. So that is so that is now 2 by 2. So it's 2 by 2, 2 by 2, and then we subtract 1 by 3. That's 1 by 3 times 3. So, and then we now move on to the other one. As we know, the signs were plus, minus plus, because we just, as I said earlier, we just alternate the signs. So we now add this one on the next step. So we have plus 3, because the 3 we just took the 3 from here, and then here also we just took the 2 from here, and then 1 here we just took it the 1 from here. So we now also multiply it out with just the 1 and have, because we are now expanding through this. As you can see, we still have a beautiful 2 by 2 matrix system. So we now have 2 by 1 and then 1 by 0. So the answer is 2 times 1, 2 times 1, and then we subtract 1 by 0, which is 0. So we're now subtracting 1 by 0. Okay, so we now just find out what the answer of this is. So it's 1 here multiplied by 0 by 2, it's 0. So it's 0 minus 1 by 3 is 3, and then this part we are done. Move on to this minus 2. So 2 by 2 is 4. So it's 4 minus 1 by 3. So it's minus 3. 4 minus 3. And then we are now done with this part. We move on to the other part, which is now 3 is plus 3 by 2 by 1, which is 2. That is, sorry, it's 3. 2 by 1 is 2, and then minus 1 by 0 is 0. Okay, and then we can just further compute that one. So this is minus 3, because 1 times minus 3, then get minus 3. Minus 3, then minus 2. This was supposed to be 1, so 1 time is just let me just write it clear for you. So this one reduces to 1, and then this one is just a 2 here. Then this is it's a minus 3. Yes, so it's 2 times 1 gives us the answer of minus 2, because we are saying is minus 2 times 1, so it's 2, and then plus 3 by 2, which is 6. So it's 6 plus 6 here, and then the final answer will be minus 2. Minus 3 minus 2 is minus 5. So the determinant of this one is the final answer is 1. So that's very simple and straightforward. But we can also expand through any other row, and then you just get the same answer. So if you want me to do that, I will do that one in the next lesson. You guys subscribe my channel, and then I'll update you of any other problem that you have. I'm here to help you. So let's pass mathematics, and then share with your friends, and then also invite others to the group. Thank you for watching. Until next time.